This is second video on statics of non-planar forces. Uh, they are also called space forces. And here in this video, we are going to solve three problems on this topic of space forces. First one says, determine the magnitude and direction of the force F, which is given by 345I plus 150J minus 290K. This is fairly simple problem where the magnitude, you have to understand that force can be expressed like this, that is magnitude into direction cosines, and therefore you see the magnitude is simply 345 square plus 150 square plus 290 square under root, that is 475, and because fx, that is x component, is f cos alpha and value of f is known 475 and fx is 345, we can easily get alpha, which is the inclination of this force with the x-axis. Now similarly, we can write fy as f cos beta, put fy as this 150, magnitude 475, and then 150 is 475 cos beta, you get your beta, and similarly you get gamma. So we answered the question, that is we have found the magnitude 475 and we have found inclination with each of the axes, that is angles alpha, beta, gamma. So I completely answered this question. Next question says, a force acts at origin in a direction defined by theta y equal to 65 degree and theta z equal to 40 degree, meaning the force is inclined to y-axis at 65 degree, to z-axis at 40 degree. Knowing that x component of the force is 750, we are to find other components, that is y and z components, and magnitude of force and value of theta x. Theta y and theta z are given. So they want to know the inclination of this force with x-axis. Okay, we'll look at it like this. In these three dimensions, force can be expressed like this, and we have been told that f cos theta x is 750. And we know from the property of direction cosines that these squares of cos must add to 1. Now these two give us clue as to how to solve this problem. See, we know theta y, theta z. So if you put this in equation, if you put these values in this equation, we get value of theta x. So we know inclination of this force with x-axis. Now, this f, this 750 is f cos theta x. You see from this you get, and f is a magnitude which you want to find. So since we have found theta x, we can easily find f, and having found f, fy is simply this f into cos 65, and fz is this f into cos 40. So we have not only found inclination of this force with x-axis, but also we have found its other components and the magnitude of this force. So let's go to the third problem, which says the lines of action of three forces concurrent at origin pass respectively through points A, B, C, whose coordinates are given here. See, x, y, z of each of these points are given. The magnitude of the forces are 40, 10 and 30, and we want to find magnitude and direction of the resultant. So what, see, the entire complete data required is given. What they are saying is force passes through origin, and first force passes through these 3 points, second force passes through these 3 points, and third force passes through these 3 points. So we will write each of these forces vectors as explained in the video 1, which we may want to refer. So F1 will be magnitude. Into this, see, you write these coordinates I minus I, 2j, 4k, and here this 4.8 is nothing but 1 square plus 2 square plus 4 square under root. So this is a complete expression of F1 whose magnitude is 40, or we could have called it Fa also. So this complete expression in vector form is here F1. Similarly, if we say magnitude of this F2 is 10, then we can express F2 as vector in this manner in the exactly same way. 3i minus 3k is here, and 4.24 is nothing but 3 square plus 3 square under root. Similarly, we write F3, and then the resultant will be simply addition of this F1, F2, F3. We have just simplified this, and then we take all the I components, J components, K components and add up. So we get R, the resultant force in a vector form. And once you have the resultant in vector form, its magnitude and direction are easy to find. See, the magnitude is 53.665, and then each of the angles you can find 10.59 upon 53.665 cos inverse, you get theta x. Similarly, you will get theta y, and similarly you will get theta z. I think is a small error. This should be z. So cos theta z is this, and so you have inclination with all the inclination of resultant with all the axis, and also you have the magnitude of the resultant. Please note this should be theta z. Okay, thank you.